2023 problem solving session on signals and systems. Totally in GATE 2023, from SS, 1 mark questions are 5, 2 mark questions are 5. And these 2 mark questions, 3 questions are MCQs and 2 questions are NET, numerical answer type. Totally the weightage and GATE 2023 for SS is 15 marks. Okay. So now let us see the first question. Consider a system with input x of t and output y of t equal to x of e power t. The system is given 4 options. So first I'll check the answer A. So what is a causal system? A causal system is one for which the output at any time t depends on the present and past inputs. Present and past inputs. Output depends on present and past inputs. That is called causal system. If the output depends on future inputs, this is called non-causal. Non-causal. Now let us take the output y of t equal to x of e power t. So now take t equal to 0. I'll get y of 0 equal to x of e power 0. X of e power 0. E power 0 is 1. So x of 1. What is this y of 0? Present output. What is x of 1? As 1 is more than 0, you have to consider this as future input. So as present output depends on future input, according to the definition of causal and non-causal systems, the system is said to be non-causal. The system is said to be non-causal. So the options A and C are not correct. So now we have to check for B and D. Okay. So means already non-causal is over. We have to check whether the system is time invariant or variant. Then what is time variant and invariant systems? Take a system. Take one input x of t and one output y of t. There exist two things. Output due to delayed input. Okay. Let us represent this with y of t comma t. And another one, output is delayed. Represent it with y of t minus t. Okay. How to connect these two with our system? First give x of t, you'll get y of t. After that, you introduce a delay in x of t like x of t minus t. And for this, the corresponding output is, let it be y of t comma t. Then, for the same x of t, you'll get y of t now. And in this y of t, you introduce a delay like y of t minus t. Okay, if these two, this y of t minus t and y of t comma t both are same, if y of t comma t is equal to y of t minus t, if both are same, the system is said to be time invariant. Time invariant. If y of t comma t is not equal to y of t minus t, then the system is said to be time variant. Time variant means the delay introduced at the input side or the delay introduced at the output side, it won't change the system. It won't change the system characteristics. Then that system is called time invariant system, and if the two are not same, that is time variant. So now for our system, now we'll see y of t comma t. For the given system, y of t equal to x of e power t. What is y of t comma t? Output due to the delayed input. So what is this? X of e power t is your input. You must delay it. Let it be x of e power t minus t. And what is y of t minus t? Simply it is delayed output. Y of t minus t is x of e power t minus t. Okay, so this is the output due to delayed input. This is the delayed output. So if you observe these two, you can say y of t comma t is not equal to y of t minus t. Hence the system is said to be time variant. Time variant. Okay. So what is the answer? Answer is B. Next question. Let m of t be a strictly band limited signal with bandwidth B and energy E. Assuming omega naught equal to 10B, the energy in the signal m of t cos omega naught t is. Okay. So what is m of t? M of t is a band limited signal. Band limited signal with the bandwidth B. So you can draw now for a band limited signal m of t, the m of omega like this. This is minus B and this is plus B. Amplitude is 1. Then the energy E in this band limited signal, energy E in the band limited signal m of t is 1 by 2 pi and the limits minus B to B mod m of omega whole square d omega. Okay. So 1 by 2 pi integral minus B to B. What is mod m of omega whole square? 1 d omega, because the amplitude is 1. So the answer is 1 by 2 pi B plus B is nothing but B by pi. What you have to find? You have to find energy in the signal m of t cos omega naught t. Now take y of t as m of t cos omega naught t. We know cos omega naught t can be written as e power j omega naught t plus e power minus j omega naught t by 2. Okay. Then from the property of multiplication with complex exponential, we can write y of omega or Fourier transform of this expression, this total expression as 1 by 2 of m of omega minus omega naught plus m of omega plus omega naught. If you multiply the signal with complex exponential, then there exists a shift in frequency domain. Okay? Yes. So m of t, Fourier is m of omega. Then as m of t is multiplied with e power j omega naught t, that m of omega gets shifted. That is m of omega minus omega naught, and for the next term it is m of omega plus omega naught. Okay. So how to plot this? See the plot. Y of omega. Yes, y of omega consists of two replicas of your m of omega. One is centered at omega naught, another one is centered at minus omega naught. So let be omega naught, and here is minus omega naught. So for this first term, is you have to keep this m of omega here as omega naught as center, like this. And here also you have to keep another replica. And given omega naught equal to 10b. So obviously this, as this width is 1b, so this becomes 11b. And this becomes 9b. And here it is minus 10b. So it becomes minus 9b, and this becomes minus 11b. And what is the amplitude? The amplitude is 1 by 2. So now the energy in y of omega is, let be E dash, is same 1 by 2 pi. Actual formula is integral minus infinity to infinite mod y of omega whole square d omega. Here also. But here it is a band limited signal, so the limits becomes minus b to b. Okay, now here also according to this spectrum you have to take the limits. So 1 by 2 pi will go from this. Integral minus 11b to minus 9b. What is mod y of omega whole square? 1 by 2 1 by 2 whole square d omega plus integral 9b to 11b 1 by 2 whole square d omega. So if you compute it, you're going to get E dash as 1 by 2 pi 1 by 4 of 1 by 2 pi 1 by 4 integral d omega is omega between the limits minus 11b to minus 9b. Again here also 1 by 4 omega between 9b to 11b. If you calculate this, you're going to get b by 2 pi. B by 2 pi can be written as 1 by 2 of b by pi, which is nothing but 1 by 2 into E. So it is E by 2. See here, B by pi is E. So the answer is E by 2. So the next question is, find the Fourier transform of this signal x of t equal to e power minus t square. We have a standard result. The standard result is e power minus at square is in pair with root pi by a e power minus omega square by 4a. That is a standard result. Okay, e power minus at square and root pi by a e power minus omega square by 4a both are in pair, Fourier transform pair. It's like Gaussian, it's a Gaussian function. So here if you see, only a is missing, means you have to take a1. So implies, what is x of omega? X of omega is simply keep a1 here. So the answer is root pi e power minus omega square by 4. The question is about the spectral characteristics. I'll tell you how the spectral characteristics of various signals. Try to remember all these points. For continuous signals, before that, let me explain what is spectral characteristics. Spectral characteristics. Spectral characteristics means simply frequencies on x-axis amplitude on y-axis. Means it is the plot of various frequency components and their amplitude. That is called spectral characteristics. Okay. So for continuous type, to get these frequency components in a continuous signal, we go for Fourier series expansion. Fourier series expansion. And we know Fourier series expansion consists of various frequency components, harmonics, even harmonics, odd harmonics, etc. So this Fourier series expansion is aperiodic. So for continuous signals, the spectrum is aperiodic. And for discrete, in the process of discretizing a continuous signal, we are sampling with the time interval, specific time interval. So that creates aperiodic spectral characteristics. The spectrum is periodic for a discrete signal. And if the signal is periodic, for the periodic signal, to get various frequency components, we generally go for Fourier series. And if you, even for the periodic, you can apply Fourier transform also to find the spectral characteristics. For periodic signals, the spectral characteristics are discrete. It consists of, actually the Fourier transform of periodic signal consists of impulses at regular intervals of time, means a discrete signal. And for non-periodic signal, the spectrum consists of continuous and unpredictable frequency components. Okay, so now if you connect all these things, the answer is C. Answer is B. Okay, up to this is signal type, and these are spectral characteristics. One is mapped to A. If the signal is of type continuous and aperiodic, the spectrum is continuous and aperiodic. Okay, means you have to combine of continuous and aperiodic. So you will get both spectral characteristics mixed. So continuous aperiodic, continuous spectral characteristics are aperiodic. Aperiodic spectral characteristics are continuous. So totally you have to club aperiodic and continuous. So this is the answer. Okay. Then see continuous and periodic. Continuous and periodic. So you are going to get aperiodic and discrete. So the answer is discrete aperiodic, means 2C. Same way for discrete aperiodic. Discrete and aperiodic, answer is periodic and continuous, means continuous and periodic. 3B. Discrete periodic, discrete is periodic, periodic is discrete, so you'll get discrete periodic. Okay. So this is about spectral characteristics. This is a question. For a real signal, which of the following is or are valid power spectral density or densities? Okay. Among these four, we have to find valid power spectral densities. Actually, it is MSQ question. It is MSQ question. Multiple select type question. So first, I'll tell you two main properties of power spectral density. Power spectral density. Two main properties of power spectral density. The first one is the power spectral density Sx of omega must be greater than or equal to 0. That is the first property. And the second property, the power spectral density Sx of omega is even. These are the two main properties of power spectral density. So now if you observe, is it an even function? See, as the two are graphs, first you'll see these two. Even function? No. It is not even function. Okay, it is odd. So this is not the answer. This is also not an even function. This is not the answer. So now as it consists of cos, it is even. It is also even. It is the cos equivalent. And now we will check for whether Sx of omega is greater than or equal to 0. So if you keep omega equal to 0, here you are going to get some value. Here also you are going to get 1. Here you have Sx of omega even for less than omega. Sx of omega must be greater than or equal to 0. But it has minus 1, so this is not the answer. So totally the answers are A and B. Okay, I think you understand. This is not even. This is also not even. These two are evens. What is actually even function? Even function means x of minus t equal to x of t. Here, as it is in omega, x of minus omega equal to x of omega. Okay, so Sx of minus omega must be equal to Sx of omega. So keep omega equal to minus omega here. As it is square, it becomes simply omega square, means it is an even function. Here also the two consist of squares, it becomes positive. So this is also even. So the answers are these two. This question is This is x of e power j omega and is passed through an LTI system, and the LTI system frequency response is h of e power j omega. You have to find the output y of n. Very easy. You know, for the LTI system, if input is x of e power j omega, output is y of e power j omega, and the LTI system frequency response is h of e power j omega. These are all in frequency domain. Then these three are related. Y of e power j omega is simply x of e power j omega into h of e power j omega. So you have to multiply 1 minus e power minus j omega plus 2 into e power minus 3j omega into 1 minus half e power minus j2 omega. Okay, if you multiply, you are going to get 1 minus e power minus j omega minus 0.5 e power minus j2 omega plus 2.5 e power minus j3 omega minus e power minus j5 omega. This is y of e power j omega. And the concept of j transform, z is actually r into e power j omega. But for its stable system, r is 1, unit circle. So as r is 1, z is e power j omega, omega or this omega, this notation you can follow. So now if you write this expression in terms of z, your y of z is equal to 1 minus z power minus 1 minus 0.5 z power minus 2 plus 2.5 z power minus 3 minus z power minus 5. So now apply inverse z. Inverse z. You will get y of n equal to, for 1 the inverse z transform is delta of n, and next for z power minus 1 it is delta of n minus 1, and next minus 0.5 into delta of n minus 2 plus 2.5 into delta of n minus 3 minus delta of n minus 5. So this is your y of n.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.